Hi, my name's Evan, and I'm here at Sarah Laser. I'm going to be doing your LightBOT demo today. Um, at the moment, I have the CRX 25 kilogram collaborative robot. And then over here, I have the LightWELD 1500 XC is what I'm going to be using today for this application. So LightBOT is it's a co-robot system, which we have done the integration here at Sarah Laser. I'm gonna turn the robot a little bit so I can show you the gun. So what's included with this package is, depending if you already have a LightWELD or not, it'll come with the robotic arm. We have the mount here. The mount you can configure a few different ways. Right now I kind of have it in its shortest form. Typically there's like a can that spaces the gun down a little bit farther. Let me show you that one. So if you see that little cylinder there on the end of the robot arm.
Okay.
So that I just have mine shortened right now. For this application, it doesn't really matter. If it was a little bit longer. But yeah, and then the mount here is on the other side here, there's a clasp, and then you can open a door and then take the gun out. So you can use it in a handheld fashion if you want. But so the kit comes with the all the hardware needed to mount the gun and strap the cable onto the robot. There's also a teaching tip, which I'll show you here. So on the end of the light weld, there's typically an opening for the laser to go through. You'll put this on when you're teaching your points, so you can teach the robot where you want the laser to actually hit. This is like an accurate depiction of the laser's trajectory there.
And I don't think they have a light weld either, Evan.
Okay.
Yep.
Yeah, I'll just kind of talk about the light weld also. So the light weld is it's a handheld laser welder system. It uses an infrared laser beam in order to focus photons of light into a very small spot on your surface, which will then melt the metal and create a weld. Laser welding is well proven in an industry. It's been around for quite a while. It's just kind of new to the handheld market. And the benefits of laser welding are that you can get very fast travel speeds on your weld. So you're typically the welds are about 4 times faster at least than a traditional TIG weld. Another benefit is that you get really deep penetration into your material. So you can get up to, with this system right here, you can get about 3/16 of weld penetration into the material. So 3/16 of an inch just directly into a piece of metal. It doesn't even have to have a weld joint there. And you can push those limits and go with more weld penetration. You just got to tweak the settings a little bit. And also you have really fine control over the energy. So you can actually weld much thinner materials also. So I've been able to weld down to 5 thousandths stainless material with the same welder that'll weld up to a 1/4 inch penetration. So yeah, and there's also a few different models of light weld. So the one I have here is the XC. There's actually 4 models in the lineup of light weld. This is the lower end of the middle range. So it's considered a multi-mode laser. It has a little bit of a larger spot where the laser hits the material, so it gets a little bit less energy density in your weld. There's also the XR models of the welder, which have a finer spot to the laser beam. Gives you higher energy density, a little bit more weld penetration, and better performance with aluminum. And then, there's the very basic light weld, which will, for all intents and purposes, weld the exact same way as this LightWELD XC. This XC just has the feature of cleaning, so it can do laser cleaning of the material. Have you guys looked into the LightWELD system already?
Yeah, do all of those Can all those be automated or, on
Any
a
of them can be
robot or,
automated.
okay.
Yeah, the programming software that we've developed for this will only work on a Fanuc robot. So you can buy the kit, the kit to mount the gun to the standard robot mounting face, and put it on any robot you want really, but you won't have any of the integration that we've done as far as the giving it commands and being able to control the laser parameters through the robot, unless you use a Fanuc. Yeah, but any of them, even if you had a LightWELD previously, you'd be able to put it on a robot with just a software update. Okay, and then the Fanuc arm. So yeah, this is a 25 kilogram CRX model. I'm going to kind of show you the size of it here. Turn it sideways a little bit. So you can see, the table's at my waist and I'm reaching up just to the top of this arm, and this is kind of in its zeroed out position. So once this arm reaches up, it's about another 3.5 feet tall. So this is the largest collaborative robot available. You may depend based on the angle that you may need to weld. So you do need to kind of maintain a certain angle during weld. So if you're reaching real on the back side of something and the front side of something, you may actually need the larger robot to reach like all around something that's, say, square, for instance. But if you're doing something that's pretty much always on a flat plane, you may also be able to get away with one of the smaller arms. So this is the CRX 10 here. So you can see this one's just a lot smaller. And you can do all sorts of stuff with this. It's just mainly when you get into these reaching on the back and reaching on the front side is when you need that extra reach. But we can figure out the size that would suit what you're doing at another time also.
Yeah, we currently have some of the Fanuc robots. But I'm not sure exactly what model we have. I don't think they can articulate like that one.
Okay. Are they yellow robots?
They
Yeah.
are.
Oh, okay. Yeah, gotcha. So the beauty of the collaborative robot is, let's see, is that I can just work with it, with my hands. So if I want, I can actually teach my entire welding program like this. Just, putting it into position, recording a position, moving it on to the next position. Once you teach your tool center point, you can see that it'll actually move about the end of the torch if you tell it to. You can also put it in a setting where it will maintain the torch angle. So you can see no matter how I push this right now, it's going to keep that angle the same. It's a good benefit to be able to move it by hand. However, you can also just program your welding and your robot movement in the traditional sense with jogging. That's kind of my preferred method. I just put it in this jog mode, and I can either move it in relation to the joint. So you see right now, I'm just going to move only the 6th joint to the gun's rotating. If I want to move the 4th joint only. If I want to move, J1, which is the base of the robot, J2, 3. So I can do it in joint. I can also move it in coordinate system. So in Cartesian coordinate system. So if I do the right hand rule, X is going to be away from the robot, Y is going to be this way, Z is going to be this way. So if I put it in Cartesian, X, Y, Z, X minus, Y minus. So there's different ways you can move it. The collaborative nature of it's really nice though. So you can move it by hand, and it's a lot you can just not have to think, okay, I gotta go X this way, Y this way, Z this way. I can just grab it and pull it where I want it. So yeah, there's a different ways to go about it. Then the
Can you show them the
programming.
icons?
Yeah, I'm about to get to that right now. So the programming looks like this. This is the peach pendant here. So you program in a timeline. So it reads left to right, just like a book. So you'll put your icons in, and then you select from your icons here in the programming menu. This is my history. So these are all the ones that I ever use. There's actually a couple more in here that I was just experimenting with, but that I don't use. So I keep it really simple, and I've done pretty much all of my welding applications with, 80% of what you see right there. But you also have a lot of options. This is all of the icons. So if you find a use for them, you have lots and lots of capabilities here for different types of actions and commands. The ones that we've developed specifically for the LightWELD, including laser on, laser off, etc. Set program, wire speed for wire welding, all of this. These are the ones that we've developed here that send communications directly to the LightWELD. And yeah, so that's kind of how it works. You basically will, let's go down here. I'll input an icon. Let's say I was going to do a laser cleaning. I would just drag it up into the timeline like that. You can see I can actually move it in between. I don't know what I did, so I'm going to hit undo. Oop, undo. I can drag it in between other icons if I want. I can copy paste. I can delete. I can switch it out for another icon. I'm just going to delete it since I'm not using that. So it's real easy. It kind of just makes sense. You just one icon at a time. If I wanted to make adjustments to any of these icons, I could just click on it. It would highlight in blue. It'll show me the parameters that I have set. So for instance, this is set program. I'm just basically setting my weld program here. So for these spot welds, E5 is a timed spot weld. I have it at 1,000 watts. I'm actually going to lower it based on a couple of tests that I did. I think I can get away with a little bit less power. So I'm going to go 800. So let's move on. Details of a motion move for the robot. This is a linear move here. This is a joint move here. So for the linear move, I can view the actual data of the position. I can directly edit this by just changing these values. I can click on it and then change the value. And then I can touch up the point and it'll override the original. Or I can just move the robot and then click touch up and it'll override on its own. So here's the touch up button. I can also move to any position. I can just pull this slider and it will move to those coordinates. So right now the robot is moving to. Laser on. You can set a couple timers and ask it to turn on auxiliary devices or the wire feeder. Laser off. Again, some timers. You can deactivate devices such as like a rotary device or something like that. Yeah, and so that's pretty much it as far as how you program. Do you have any questions about any of that?
No.
Okay. All right, so I was looking at your part here. I did a couple of tests. So I fixtured it up as good as I could with the tooling that I have at the moment. It is a little bit tricky to get these to sit flush on here without a proper fixture. So
Yeah.
we may have a kind of hit and miss whether it's actually the tube materials are actually touching or not. So you can see here out of these, I just tried on this one here. I got 3 to bond, 3 of them didn't. And that's just because I'm assuming the material is not, you know, it's kind of like this. I was looking at these and they're
Yeah, we
not
kind of have
perfectly.
to clamp it down pretty
Yeah.
tight as of right now.
Yeah, so that's going to be probably the same thing. So if you see a couple hit and miss spots here, just consider that. But yeah, what I was going to do is go ahead and, since I've already done this one, I was going to go ahead and start here in my program. And then, or what I'll do is, you know, I'll let it run through these positions, but I'll have the laser deactivated. And then right when it finishes this one, I'll have it turn the laser back on and go through the rest of them. Did you have any other questions before we go ahead and do that?
I don't think so.
Okay.
Ever good.
All right. So just in case I didn't mention, this weld is being done with nitrogen shielding gas, with the LightWELD XC. And yeah, we're using the spot weld or the tack weld function, but turn in the power so that it'll penetrate through, you know, multiple pieces of metal here. So make one little adjustment. Oops. And yeah, so I'm gonna go ahead and click run. Would you guys rather be zoomed in on the part a little more, or do you want to see the robot arm moving also? I can
The
zoom it.
part.
Oh,
Yeah,
part,
zoom in
okay.
the part, yeah.
Okay. Yes, okay, so I'm gonna go ahead and flip down my laser welding helmet. So actually, one more thing to mention, laser safety is pretty important. So there's special eyewear, special helmets to use during this, and it's very important. The light is different than arc weld. So just keep that in mind. You know, you will have to consider some safety things that you might not have had before with personnel safety and stuff like that. But I could talk more about that after also. Okay, I'm gonna go ahead and play it. And all of these, you know, the timing of all of this can be tuned in. I didn't have too much time to dial all this in there. You know, we can definitely try to make it a little more efficient time wise and stuff like that. There we go. Also, there's many ways we could do this. We don't need to do these 3 spots. You can do a line that'll go through both of them. I just thought that the spots were representative of what I saw in the picture and definitely a possibility. But there, you know, you could I'll show you an example of something I did by hand, which may also be a good way to do it.
And so that one, that's not like the fastest travel speed the robot can go.
No, you can go faster. I think you would have to kind of change some settings in the dual check safety system of the robot. There because I'm standing right next to it, there's some
Yeah.
there's some limitations to it, but you can, for instance, have like a certain safe area where maybe you'd put the, the tablet cord is pretty long. So say I was standing back here and the robot couldn't reach me and I had like a tablet here and I had to start it from over here, then you could kind of change the safety parameters. But because I'm up close, I haven't made any changes to this robot. It's just how it is. But I think you can
Okay.
go almost twice that fast. And then obviously the weld cycle time takes what it takes, but the intermediate moves you can definitely speed up. Okay, so I'm gonna take this out of here and show you. I did a little bit of testing also, I'll show you that after, I guess, but so the ones that I did right here are the ones with the folded sections. I also did some testing with just the single wall section. It will definitely require a different power setting. Almost like half as much power. Yeah, let me zoom in on this for you. Is this aluminized steel? Am I right with that?
Yes, it is.
Okay. I was hoping it was not galvanized because this wouldn't work very good if it was galvanized. So I was happy to
Yeah.
find that it seemed to be aluminized. So it looked like all of those ones worked just fine. You can see the very first one, it must not have been touching because it just kind of went through, made a hole.
Yeah.
But all of the ones in the middle worked pretty good.
Can you see the other side? Yeah.
So you can see it coming through. If you wanted a little bit less of that, it would be simply a matter of turning the power down.
Right.
I have it at 900 watts right now is what I put it at. I noticed that when my testing, I was on 1,000 and that was too much. So that's why I dialed it back to 900. Maybe at 800 would have been better. Are these for food or something?
They are. Yeah.
Baking trays? or
Yeah.
something?
They're commercial baking pans. Yep.
Got it. Okay. So I'm assuming you probably want to not have the burn through, right?
Right.
Okay. That's definitely possible, especially considering that we have 4 layers of wait, 1, 2, 3, no, 3 layers of metal on these
Yeah.
folded sections. You'd definitely be
Yeah.
able to just turn it down and still get good penetration on these spot welds.
So if I could,